fundamental question, what is coal? And no matter where you go, you get a different answer. And it's deliberately wordy because no one quite agrees, even down to, is it sedimentary or is it metamorphic? And the consensus answer is it's kind of both, depends on when. But it's got a wide use, and a use as a natural fuel for power, and also in the steel manufacturing. That's its two big ones. And it's important to remember that there is no such thing as a metallurgical coal or a thermal coal. Coal is defined by its end use. The person buying the coal decides what they're going to use it for. And they're the ones who define whether it's a metallurgical or a thermal coal. We'll come back to that one a little later. So, coal's complicated. It's made up of lots and lots of different constituent parts. It's made from plants that died and fell over in a swamp and got buried by dirt, and then mixed up over time, and it's got stuff in it that's useful, like carbon, and it's got stuff in it that's not useful. So mineral matter, the dirt it was buried with gets mixed in with it, and it gets deposited at the same time. And understanding all of that is really important. So, in a picture, we have trees that die and form into a swamp, and peat, and I'm sure everyone in Singapore is familiar with peat and what happens when it burns underground. Peat then, subject to depth and pressure over time, turns into lignite and then into black coal. The process is relatively simple conceptually, but the process for each coal is unique. So how deep it's buried, how much heat, what mineral matter went into it, what plant matter went into it, what type of plants, and that has a big impact on what comes out the other end. So if we run through the types of coal, peat is the start. So this is one step beyond what's in your compost bin. It still looks like plant matter. You can still get twigs, you can still get sticks in it. High organic, lots of water in it, bogs, it's not really a coal. So historically used, countries like Ireland have thrived on this for home heating, but not strictly a coal yet. It is an organic material. We go a little further on and we get what's called a lignite, or brown coal, you'll hear it. And it is, it's brown in colour, brown in the ground. And this is when it's considered a sedimentary rock, it's coal. Almost exclusively in the past, people have used this for electric power generation for steam. So burn it, energy, but there's more water than carbon in it, so generally not transported. In the last 5 years, some of it has been put on ships and transported. Then you get to bituminous and subbituminous. So, apologies, there's a mistake there. This is black coal. Okay. Sorry, we have a mistake in editing on that one. Okay, black coal. This coal has undergone what's called a coalification jump. And what's happened there is you've had the destruction. You can no longer see wood. You can no longer see bits of sticks. It's lost all of that plant structure and turned into a rock. So normally there's an associated decrease in moisture. Now, something unique about Indonesian coals is that it undergoes that coalification jump to subbituminous without the reduction in moisture. So a mistake you'll often see is people using classifications that come out of North America or the UK and go, that's a lignite. So no, it's black, it's hard, it has no woody structures, it has vitrinite, it has macerals formed. It's a bituminous or a subbituminous coal. Beyond that, you go to anthracite. And at this point, this is the rarest of all coals. And at this stage, it's considered a metamorphic rock. It's been subject to a lot more heat and pressure. Carbon content's typically over 80%, and very little else is in it, 80 to 90%. So Vietnam is probably the world's leading source of this coal, but it does exist elsewhere. Truly some interesting deposits in Canada coming up on this. And all of these exist in Indonesia. So, just in summary, we go from wood, and with the application of temperature, time and pressure, we go to brown coals, these big things here like you see, that's a coal seam, all of that with this massive piece of equipment, through to what's called a rock, and that's your black coals through to an anthracite. The transition from there is called rank, and you're going from low rank to the highest rank. Rank is really important when you're marketing the coal and determining what you can use it for. So wood, building houses, burning in a fire. Brown coals, you're burning again, through to out here in anthracites, heating, burning again, and sometimes into the metallurgical process with PCI. This one here is where you really want to be, your subbituminous and bituminous. So that is the coal that is used in heating, it is used in metallurgical processes, it is the bulk of the seaborne market. So, Indonesian coals and ranks, so where do they sit? They're all young. Okay, none of them are particularly old. So, that earlier statement, Indonesian coals don't fall neatly into ASTM classification. So, the American classification, if you take your average coal from, say, Muara Wahau, and you apply ASTM classification, you'll say it's a lignite. But it's not. It's black, it's hard, it has no plant structures in it, it has the presence of vitrinite and other masterals. So it is not a lignite geologically. So the coals are unique in that their rank is accelerated by local heat sources, so magmatic intrusions, or in the case of Kelton Prima coal, it's called a mud diapir, a big bubble of mud. And geology is full of words like diapir. It's, they love their vocabulary. The process by which it's happened that these coals have increased in rank, become subbituminous without the decrease in moisture, is not well understood. So, rank is a lot more closely associated with a proximity to a heat source in Indonesia than other factors. So you can't say at any area is like X. Within a particular area, you can get rapid changes in rank over very, very short distances. There are single concessions that have lignite and high rank coking coals in the same concession. So anyone who comes to you and says, my concession is next to, you should treat with care. And that's really important in Indonesia, and something unique about Indonesia is that rapid change in rank over very, very short distances. Last comment I'll deal with later about laboratory analysis. Moving along a little bit to what that means in its uses. Coal is classified by its end use, nothing else. If we look at the World Coal Organisation statistics for exports from Indonesia, there's almost no coking coal. But if we look at Japan import statistics, Indonesia is the second largest supplier of coking coal to Japan. The disconnect is just in the classification. Okay, the person selling it doesn't necessarily, although they should, know what it's going to be used for. So it's not about a particular type of energy or swell or fluidity, it's what am I going to use it for? But we have two broad classifications that you need to remember. Thermal coal, it's a heat source, you're going to burn it, you're going to make power from it. Coking coal, or metallurgical coal as it's otherwise known, we're going to make iron and steel out of it. Now, there's a big degree of substitution in it. There are coals, Adaro coal, for example, is one of the earliest coals, PCI coals, as a substitute for high-value coking coals in the steel-making process. So there's a large degree of substitution. So, thermal coal, burnt, easy. Coking coal, active chemical and physical part of the metallurgical. When you're considering the two, the range of quality, the range of parameters you're doing are just completely different. And in thermal coal, you're interested in calorific value. You never mention that in terms of a coking coal. So calorific value, ash, sulphur, moisture, that's the major list for a thermal coal. For a coking coal, the list is 2 pages long. And you've got things like crucible swelling number, fluidity, Gray-King index, coke strength after reaction, and the list keeps going on. It's really important to understand which one of these you've got because there's a big difference. Although we're talking $90 for thermal today, we're talking $145 for a hard coking coal. So not understanding that can actually make a huge difference to the value of your project. And I just want to go into one particular aspect in detail in terms of the properties you need to understand to figure out which coal you've got, just to give an insight into the complexity that is coal really. So as far as coking coals, in particular, remember we took rank. Rank tells you where you are in that, have I got a piece of wood, have I got a low rank coal. Vitrinite reflectance is the #1 measure. And coking typically has a reflectance greater than 0.7. A good coking coal, 1.1, 1.3 is nice. If it's going up to 1.6, it's probably overcooked and it's more like an anthracite. So, and you go, vitrinite reflectance, what's vitrinite? And I mentioned it a few times, so I thought I should explain it. So coal's a sedimentary rock, but basically it's plants that died. The organic components that are identifiable under a microscope are called macerates. And you know, having spent enough time as an undergraduate looking through a microscope at macerates, it's not that exciting. But you've got 3 main groups: liptonite, vitrinite, and inertinite. And vitrinite's the exciting one. That's the reactive one. That's the one that takes a chemical part in the reaction. Inertinite's the boring one. It's inert. But it gives you strength in your cokes. So, piece of coal under a microscope in here, and we have up here the bright bit, vitrinite, but this is not particularly bright. Micronite is another type. They have sub-classifications into it, which I won't go into in too much time. But what you're looking at here is you shine a light at it and how much reflects. And really, this is your best measure. By definition, a peat or a true lignite has no reflectance because there cannot be any vitrinite. If you form vitrinite, it cannot be a peat or a lignite. So your low rank subbituminous, they're around 0.2. So Moira Wahal, that area. And that, again, proves it's not a lignite. And bituminous coals are up to 0.7. And then if you're getting a reflectance above 0.7, and that's like Kartika Salabumi, around 1.2, then it's really well worth going further and looking at your coal as a coking coal. Unfortunately, that test can't be done in Indonesia today, and that's yet one of our other challenges. So that's what is coal, how it's formed, and a little insight into just one of its properties, the vitrinite. And remember, there's about 2 to 3 pages of that sort of analysis that we have to go through.